Good evening. This is presentation of new module of time domain electromagnetic software for processing of multi-stacked or multi-repeated data. Currently, it's supported three formats for UCF of Charlie Stoyer, stacked data, GX7 of Geonix for multi-repeated data, and BEM. This is internal format of instrument. So we will start this model. It looks like very similar to the model we made for magnetotelluric, but it's a little different. We will start with Geonix data, because it's all repeats contains in one files. This model support processing of three components, but if you have just one, use to Z components. It's very typical. It's okay. So first of all, what I can see here after opening this file, this table allow to select repeats or realizations together for processing together, because here every station has different coordinates. It's already merged. So this white and silver cells means stations, but we have different options for sorting this table and for merging. Also, it's possible to do merging of records this mouse, and I'll show you it later on another data. So we can see all repeats here for every station, and we can change coordinates for every group of records, because here is not correct coordinates. It's not geographical, it's just station numbers. We should set it up in this table. We can copy it from Excel, for example, with Ctrl+C and Ctrl+V, or we can set it here. Also, very important to choose correct array type and measurement type. So, for example, if I need something, I change. And all group will change to this one. And now I will work without coordinates. Also, it's possible to apply all changings to all records, this changes to all records with these options. And here we also have options for fast changes sign or change sign all station. So, but this window, first window, is only for setting general settings and for the merging records to the group. Also, you can see here at various different frequencies can be used in one group, like here, and always show it up in the last column. And we can, for example, remove from processing some points we don't like. So very noisy point. For example, this point will be removed from next processing. So we can see here different parameters for this records, its post time, its current, and of course for fixed loop we have a coordinates of a receiver coil. So it can be different, and it should be set up in local local coordinates in takes loop coordinates, because these first three fields is about geographical coordinates, but this one it takes site and takes site y. This is transmitter loop with center in 0. So all Rx coordinates for fixed loop should be set up in this local coordinate system. Okay. Now we, after setting up groups of records, we can see our plane, but here I didn't use real coordinates of station. But if you have UTM, for example, you can build a map. And now the process of workflow of processing is just removing all some pretty bad points and building with approximations. Also, as you can see, error gates calculated automatically. So smoothness of these approximations depends on this trackbar. Also, if you have a positive signal or signal without crossing 0, you can use options for building approximation by raw apparent resistivity. In this case, you should turn off this option. But if you have a 0 crossing in your signal and it's natural, you should use regular way of processing. So now you can see it's very simple. We just select some stacks we like, some repeats we like, and remove which we don't like, and build new approximation. Of course, if there is some realization, some stacks with wrong sign, they can change it. Change back. Also, we can see information for every point, every realization here. So it can be used for selecting to making right choice with currents, rep types. Also, all data is converted to maximal length of pulse, so to minimum frequency, and don't need to process it separately. So all frequencies united in one point. Here we can see changing of sign, so it's crossing 0 here. So maybe we need to remove these points to these ends to get proper solution, because it's sometimes not so good with processing approximation for changing of sign in data. Also, they can process all station. Now, everywhere we can see approximations. This is red and green curves, and here is pretty bad data. So now it looks much better. So we can process this data with different smoothings and with using reference spline. I will show you later. we can save these approximations to buffer and returning to it if we don't like new options. Also here we can choose components if we have more and process it together to control how many stations we process. They can use this button because here is just one component in data. It's everything is processed and they can save data to TDEM file. It's native format for Zontem 1D software or to database. Database will keep everything, all processing step, and we can have a break, save data, have a break, and return to work if they have many points. Let's see another example. For example, it should be BAM files. It's repeats on every station with different current values and frequencies. And here they need to do combining grouping of records user defined because there is no different file names and different coordinates. It's not coordinates again, it's some number of points. But you can select cells with shift key. All this control so I selected it in 3 groups. I can check it, how every group looks like. Yes, here is something maybe from another group, but I will show us we can remove data or shift some of this. So now here I have some information about time windows, and also I can save data with user-defined numbers of time windows. This is will be divided in logarithmic domain with equal step. So here how this data looks like, and because these two records looks like wrong, I can just select it and it will not used in processing. So also very early time looks not that good. We can rebuild our spline or approximation. So I see this parent resistivity curve as a big shift. So I can move it a little with pressed S keys. If I need to move everything, I should use A key pressed, for example. It's take effect on all stacks, and also voltage will be changed corresponding to apparent resistivities. To show this menu, I should press Control. Here we can flip, flip sign, we can select stack or remove current spline. Also, as usually, always options with axes and always work here with Shift key. If we have one very good curve, and we would like to compare it or use in approximation, we should choose this point, for example, as a reference and show it and check these checkboxes here. It's a black color line right here, and we can see it, how it's look like. So for using this reference approximation in building new approximations, we should choose these options, use reference line. And now it's very close. Also, we can see previous and next sounding curves. And sometimes it's very helpful for making choice of selected point. So all this free station is processed. And we can do inversion at this point. For that, we should just save it in time domain electromagnetic format TDEM. Here is the last example for our lesson is multi-stacked UCF files. It's very many such files now I've seen. Here I have a lot of stacks per point, and here is several stations. Here is again, I can see different frequency, different pulse time. Here is how our stream looks like, the layout of stations. Decays again by group. And here I have UTM coordinates. You can see the map. It's not that good, but anyway. So here we work in the same way. For example, this point will be reference one. It's very unlike the next point. So we will not use. Okay. Choose this one as reference. For every type of data files, we can see parameters of points, current, frequency, stack number, stack index, file name. Okay, the bad point. But some stacks are not. Okay, now I can see all station, process it. This is good data. So I check, yes, everything process it. Now I can choose some parameters for exporting, minimum, maximum time window. If I would like to narrow the data set and number of times, but I will not do it. If I need, I should choose it here. And for example, I'll save it like well, it's uh, data aerial, so it's not line data. We should choose a lines here, but I will use only one. And here I can see my data, so I can do inversion. I'm not sure this is central loop array because of this part of signal. It's not looks like, but maybe it's central loop. So anyway, we can improve our version results a little. Well, maybe it's wrong array, but anyway, we got all this result with processing of multi-stacking data. Thank you very much for your attention and see you soon.